Hi all, welcome back to the channel. In this video, I'm going to solve the LeetCode question longest common prefix using binary search algorithm. I have already solved this problem using brute force approach and will post the link to that video in the description. Also, I recommend watching that video first as it briefly discusses what a prefix is, questions to ask the interviewer about this problem, assumptions and edge cases. Basically, that video covers step-by-step explanation on how to solve coding question in an interview. So here are those steps. I will include a link to this GitHub file detailing on how to approach any coding question in an interview, which you can refer. So let's go over the problem statement. Write a function to find the longest common prefix string amongst an array of strings. If there is no common prefix, then return an empty string. Let's jump right in with a couple of examples to see what we are dealing with. Imagine you have the strings flower, flow and flight. At first glance, you might notice they all start with letters FL. And that's our longest common prefix here. But what if our strings were dog, race car and car? In this case, there is no common starting sequence, so our answer would be an empty string. Like in simpler terms, our goal is to find the longest sequence of characters that appears at the beginning of each string in our list. So I won't go over what is prefix, what are clarifying questions and assumptions. You can refer this longest common prefix video which covers all this in detail, and I will include the link of this video in the description as well. So let me explain the binary search algorithm briefly. I have put detailed information about it in the GitHub repository, which I will share in the description. You can refer to it if you want to learn more. Additionally, you can pick some information from this and do Google search for further understanding. This is how I approach a new concept. Let's move on. So what is binary search? Binary search is an efficient algorithm for finding an element in a sorted array by repeatedly dividing the search interval in half, like you can see here. So it involves like maintaining two pointers, low and high, as you can see here, lower and higher, representing the current search interval. So in this first iteration, this is our search interval, and you can see in the second, this first iteration, our search interval is from 4 to 98. So basically, like in each iteration, it calculates the mid index, like you can see here, it's 35, and compares that with the target element, and based on the comparison, it updates the search interval by adjusting low or high, effectively halving the search space. Like you can see in the second iteration, the search space is exactly halved from 4 to 35. So this process continues until the target element is found or the search space is exhausted. So this is overall the main idea of binary search. So for the longest common prefix, we can exploit the fact that the length of the longest common prefix cannot exceed the length of the shortest string in the array. So let us see how we can use this binary search algorithm to solve this problem. Let me take this as an example. So how it works is, first we identify the shortest string in the array. So in our example here, the shortest string is flew with a length of 4. So we will use this length as our upper bound for the binary search. Like I mentioned before, in binary search we maintain low and high pointers as the start and end indices of the shortest string in the array. So low will be 1 here and high would be 4. Okay, so in the first iteration we'll calculate the midpoint of our current search range. That's how the binary search algorithm works. We calculate the midpoint and then we try to compare it. So here the midpoint will be the average of low and high. So mid will be 1 plus 4 divided by 2, which will be 2. So we have to check if the prefix of length 2 is common among all strings. So we will check FL is common among all strings. To do this we will use a helper function, so which will just check like whether each string starts with FL. So and if it starts, then it will return true. So we will check for all the strings in the array, and if we get that true, then we can proceed further, like we can adjust our pointers accordingly, and if we get false, then also we have to adjust our search range. So let's see here like how we can adjust that. So here FL is common among all strings, so we know that we can potentially have a longer common prefix like beyond FL. So what we will do is we will adjust our low to mid plus 1. So here instead of 2, now our low will be mid plus 1, so it will be 2 plus 1 equal 3, because our mid is 2 here. Okay, in the second iteration we will calculate the midpoint again with the updated low and high values. So let's calculate that. So here 3 plus 4 divided by 2, which is equal to 3. So our we need to check if the prefix of length 3 is common among all strings. So we are going to check what here FLO is common prefix or not, and again we will use some helper function which will just check if flower starts with FLO, so it's true. Is flow starts with FLO? Yes, true. Does flight starts with FLO? No, so that's false. So since FLO is not a common prefix, we know that the longest common prefix must be shorter, so we adjust our high now. Okay, and how we adjust that? We do mid minus 1. Okay, so what was our mid here? 3. Okay, so 3 minus 1 equal 2. So at this point now low is 3, okay, and high is 2. So low is greater than high, which ultimately results in termination of the loop. So the length of the longest common prefix we found is FL, and length is 2. I have mentioned this example in the GitHub repository, which I will link in the description. So you can go over like how this example works with the binary search. So I have mentioned everything, like what will be the low and high values in the first iteration, and how ultimately we get our longest common prefix. So you can go over this example in this GitHub. Now let me sketch my idea with pseudocode and go through the example using it. Okay, so firstly we need to have some edge cases first. Okay, so what would be like if the string is empty? We will return empty string. That's what the condition is, right? If there is no common prefix, just return an empty string. So now next would be like I would find the length of the shortest string in the array, and let us call this length as min length. Okay, so what we will do is we'll just use this integer function inbuilt max value, then iterate through the array. Oh, sorry. So whatever is the minimum, it will be returned. Okay, at the very start we have put max value in it, so we will get length of the shortest string here. Once we get the length, then we can set the initial range for the binary search. So low will be 1 and high we will get it from the min length. Okay, and then we can use a while loop which will return until like low is less than high. So let me do that. Okay, now in each iteration of the binary search we have to calculate the mid length. So we will use say middle variable to get that, and we can do this low plus high. So this will give us the mid length. Now to check if the prefix of length middle is common among all strings in the array, we will use helper function. First I'll just name it, and then I can just add more details like how the helper function will work. So we can just have something called is common prefix, and we can pass the array and the length. So, and if it is true, then we have to adjust our low to middle plus 1 as we have seen, and if it's false, then we have to lower our search range by adjusting our high to middle minus 1. I'll come back to this is common prefix API later. Okay, and then ultimately we'll return the substring of any string in the range 0 to low plus high by 2 as prefix. So we can take any string from the array and then do substring from 0 to low plus high by 2. So here we will get our longest common prefix. Why we did low plus high by 2 is like the expression low plus high by 2 calculates the midpoint of the final values of low and high. So this midpoint represents the length of the longest common prefix among all strings. So in this example as well, like you will get to know that. So here our final low was, I think here I have written, so our final low was 3 and 2, which resulted in exiting from that while loop. So the substring would return this like 3 plus 2 divided by 2, which is equal to 2, and that was our range like 0 to 2. So we will get FL as the output, because in substring, like whenever you put any value from start to end, so start is inclusive but the end one is exclusive. So yeah, so it will be 0 and 1 which would be returned. Yeah. And now coming back to this API, the helper function which we missed discussing about. So let me write down that quickly. So you can use any kind of helper function, but I would prefer using inbuilt start with method of string. So what I will do is I will use array as one of the input parameter and the length which we calculated. Then we can take any string to start the comparison. I will start just with the first one, and then we can compare this. So we will just take what's the string. After calculating the middle point, we can use the substring to extract that string. So here, say like we took flower as first string and it will extract FL. We will compare if all other strings have FL at the start. So that's the overall idea. So from the second string onwards, it will try to compare if FL is common among all the strings, and if not, then we will immediately return false and then adjust the pointers accordingly. And if it is common, then we can just return. Okay, now let us try to run this example and see. And this return true will come outside the for loop. Let us run this example and see. Oh, it got accepted. Let me submit this. Okay, there is some issue, out of bounds. Let me try and check what's the issue. So the error here, it says string index out of bound exception. Error occurs when attempting to access a substring from an empty string. So means there is no string, okay, like at that index. So the issue could be like I have used here strs.length instead of str.length. Now let me submit this. Fine. So now let us discuss time and space complexity for this one. Let me start by going over this edge case. So we check if the array is null or empty, which takes O of one time, and next we calculate the minimum length of the string in the array. This involves like iterating through each string once, making it O of n. So where n is the number of strings, right? Then here we have our main binary search algorithm. So the length of the shortest string is our upper bound, and let's call it, say, L, the upper bound. Okay, so binary search would run up till O of log L. And for each midpoint in our binary search, we check if the prefix of that length is common to all strings. This requires comparing the prefix with each string, which is O of n into L in the worst case. And combining this, the overall time complexity for the binary search part would be O of n into L into log n. Yeah, so this would be the time complexity. In terms of space complexity, we used a fixed amount of extra space for variables like low, high, then min, length, middle, and each common prefix function creates substrings, but these substrings do not consume extra space beyond what is required for the input string, since they reference parts of the existing strings. So the space complexity is O of 1 because we are not using any extra space that scales with the input size, and all operations are in place. So yeah, time complexity and space complexity for this is, I have actually shared details on how I calculated this time complexity and space complexity. If you have any doubts, please leave comments. I will try to provide more details, but I have shared all the details in this GitHub repository. Thank you.